Before Spark streaming using log file generator and TCP socket. For the log file generator, here we have the streaming context which reads data every 3 seconds. We are opening the text file stream of log folder, so whenever the content of the log folder changes, the lines are read here. Here the each record read is stored in the lines, that is the each record is a line. Now here we are splitting the line with the space, that is we are retrieving each word here, and we are mapping each word with 1 for the word count in the reducer. For the each word, that is for the same value, key value, we are adding the count here and printing the word count. Here we are starting the process, and then we are awaiting until the process is done here. Now let's run this streaming py. Here while this is running, let's go to the log file generator, which generates log files to the folder log over here. Here we have a random text file lorem ipsum. We are opening the file in the read mode and reading all the lines in the file, so all the content is stored in lines. Now we are almost constantly generating 30 log files to the folder log. We are initially randomly selecting a number, and we are reading the contents from the particular number to the end of the file and storing the data into the newly created file which we've opened in write mode, and we are writing the content to the write file here. And after the sleep of 5 seconds, again the process continues. So log files of 30 gets generated constantly. Now let's run this program as well. So here you can see the log files are getting generated. Since the log files are getting generated and the log folder is changing, here the streaming API reads from the log file and does the count. So here you can see the output while the file is still generating the log files. This streaming API is constantly reading from the log folder and displaying the word count over here. Now let's stop these two processes. For the next task, to read the data from the TCP socket, we have the word count here. Here from the Spark streaming context, we are opening the socket text stream. Here there is a TCP socket at the localhost 3000. That is the localhost 3000 acts as a web server where we give the input data, and it reads the input data from that particular port TCP socket. Here similarly we are here each record is a line, and the line has words separated by the space, so we are reading the words here and mapping each word with 1. In the reducer function, we are reducing by the word, that is the key, and adding the values to give the word count. Now let's run this file word count. So here the word count is running. Now let's create the web server that provides data to this particular socket, TCP socket. Port number 3000. Now let's this acts as a web server. Now let's input the data. see the output of this particular line with a word count with cat with frequency 2. Now let's stop this process and go to the next task. The next task is a character frequency to count the words of same frequency. Here similarly it's a TCP socket. We are reading data from TCP socket. The port is open at the TCP socket is open at the port 6000. That is a web server provides data at the localhost port 6000. Here similarly the record is each line. The line has a word separated by the space, so we are reading the words here. And here instead the length of the word acts as the key and word as the value. So we are in the reducer function, we are aggregating by the length of the word as a key, and we are printing the values, that is the word separated by comma over here. That is if the words with length 2 as a key, and the rest of the words are the values here. Now let's run this program. Okay, now let's open TCP socket at this particular port. Here the port is 6000. So now let's provide data. So here now, as you can see, here we have the words. The character frequency is 2 and the words with frequency 2 are CA and MA. Similarly, we have the output for the second line as well over here. This is all about this ICP.